Hello everyone, welcome back to my Python programming tutorial. This lesson is going to be a continuation of the first part of variables. So in this lesson we're going to talk about lists, tuples, sets, and dictionaries. So starting off with a list is basically a collection of terms. So if I go and define a variable called lst and I assign it to a collection of terms, and the way we do that is basically we use these square brackets. So before you saw them used for indexing and slicing, however, their main purpose is to define lists like this. We can say that this list will contain integers from 1 to 3 to 4. Now, if I go to log lst, you could see that it's a list 1, 2, 3, 4, and if I do the type of lst, it's going to be of type list. Python does support multiple types within a list. Again, other languages like C++ and Java, you'll have to declare type of list that you have, and you can only have a certain type within that list. However, in Python, it's cool because you can have multiple types within that list. So as you saw here, this is a list and it only has integers in it. But again, we can have integers in it, we can have floating points in it, we can have Booleans in it, and we can have strings in it. So as you can see, this works perfectly fine. And again, it will still be a list. Now, lists, unlike strings, are mutable, meaning they can be changed once we have created them. So I can go ahead and show you right now how we can do that. So again, we have that variable up here, lst, and it's equal to this list. Now, I'm just going to log it just to show you that the variable still exists. That variable lst has already been created. We can go now and modify it. The way we can modify it is by changing one of these values. And how do we do that? Well, lists are indexable just like strings. The 1 over here is at index 0, the 2 is at index 1, 3 is at index 2, and 4 is at index 3. So if we say list at index 0, we will get that 1 right there, as you see. And now what we can do is we can actually use this indexing and change the value at this index. So we can say like list at 0, and we can reassign this index of this list right here to something different. Let's do 100. And as you can see, this worked. And now if I go ahead and log that list, you could see that the 0th index of that list has now changed what we've assigned it to. So you could see why lists are mutable, because again, variable has been created up here. However, we are able to modify it down here. Unlike strings, where if I say like a is equal to hello, and then I try to do a at 0 is equal to a b, well, it says string does not support item assignment. So again, like I mentioned, strings are immutable. However, lists are mutable. Now, as you saw, lists are indexable. So again, I can go to lst and I can take the 0th index of it. I can assign that to a value. Let's say b is going to be lst at, I don't know, 2. And that's going to hold the second index of this list, which happens to be, this is going to be 0, 1, 2, so it should be the 3. If I log b, it will be the 3. These lists are sliceable. Again, this is a cool feature of Python, but we can just say lst from 1 to the last element, let's say to -1. And this will give us 2 to 3. Again, because we want to start at 1 inclusive, so this is index 1. This is the next index, and we want to go up to the last index, which is -1, but we don't want to include it. So it's just these two. The slicing operator actually does return us another list, unlike the indexing operator. So again, b is assigned to the second index of this list, and the type of b will be whatever type the list contains at that index. So the list contains at index 2 a 3, so the type of b will be an integer, because 3 is an integer. However, if we use slicing, it will return us a new list. And I can show you that if we say like this is going to be a slice, and we're going to do the same slice. So from 1 to -1. And then if I log the type of that slice, well, you could see it's a list. And again, just to show you what SLC is going to be, this slice right here. So just 2 to 3. So now that we've finished with lists, I want to move on to a tuple. And a tuple can be thought of the exact same thing as a list. However, they are just immutable, meaning you cannot change them once you create them. So the way we could create a tuple is we can say like tuple or I'm just going to call it TPL. I'm going to call the variable name TPL. That is going to hold a tuple, and basically we want to pass that tuple a list of elements, and it's going to turn it into a tuple. So let's say we pass it 1, 2, 3, 4, just like we did in the previous example. And now if we log tuple, well, it's going to be 1, 2, 3, 4. And you can immediately notice that the tuple doesn't have the square brackets. It has rounded brackets. This is one way of creating a tuple. You can create a tuple by just doing 1, 2, 3, 4. This is probably the easier way to do it and the way you want to do it. So again, that TPL variable will still hold the same stuff. These are just two ways of creating a tuple. We can index a tuple. We can say tuple at 0, and this will be equal to the value contained at the tuple's 0th index, which is the 1. And tuples are sliceable as well, so we can say tuple from 2 to the end, let's say. So it'll just be the 3. Now again, like I mentioned, tuples are immutable, and that's the key difference between a tuple and a list. So you could see that we've created the variable TPL up here, and we cannot go back and edit it like we did with the list. So we can't say TPL at 0 is going to equal to 100. This won't work. You could see the object does not support item assignment. So once we have created this variable TPL, it has to be equal to this tuple of 1, 2, 3, 4 until we reassign it. So again, we can say something like tuple is equal to now like 100, 200, 300. This will work, but again, this is not us trying to change this variable at a certain index. This is us completely reassigning the variable to something different. The key difference here is that we're not indexing it, we're assigning this variable TPL, which is the same over here, to a whole new object or a whole new tuple. Moving on to dictionaries. Sometimes in other languages these are called maps or hash map. The definition of it is an unordered collection of key value pairs. However, I'm pretty sure in Python 3 or Python even 3.7, the dictionaries are, so it would be kind of like an ordered dict in other languages. So a dictionary is, again, it's a collection of key value pairs. So I'm going to call this dict for dictionary. And a dictionary is defined by using these curly braces. Within them, what we do is we pass it a key value pair. Basically, we can say something like, okay, well, the string 1 is going to equal to 1. And that is a key value pair, where the string 1 is the key and the integer value 1 is the value. Now we can pass it a bunch of these, so we can say something like 2, and that's equal to 2, and then 3, and that's equal to 3. And now we have a dictionary. I can log you the type of dict, and you could see that it is of type dictionary. So this is a dictionary, again, a collection of key value pairs. They're separated by this comma, these key value pairs. Dictionaries are mutable, meaning you can change them once they have been created. Again, this variable DCT, short for dict, has been created already up here. And now I'm going to show you how we can go on and change it. So before, tuples and lists were indexed by a number. You would say like, okay, well, list at index 0 or something like that. However, dictionaries, they don't have this, so we can't say D at 0, DCT at 0. We can't say that because it's looking for a key that is quite literally 0. So the way you can kind of tell from this error immediately that it's looking for a key that is 0. Basically, what that means is dictionaries are indexed by their keys. So by all of these values right here, by the string 1, by the string 2, by the string 3. They don't have physical indexes like 0, 1, 2, 3. Obviously, if we were to define a dictionary, I'm going to call it dict2, that had 0 and then it was corresponding value was 0. Well, yes, then we can access, we can index this dictionary by saying at 0. But again, it's not quite literally what you think. It's not at position 0. It's looking for the key 0. And likewise, you can see with this because in a normal list, if you were to say -1, it would mean the last element. So if this were to be a list, we would grab this entire element. But here, you won't be able to do that because -1 is not a key. So the main point that I'm trying to get across is that dictionaries are indexed by their keys. So looking back at this example up here, DCT, well, DCT has 3 key value pairs, meaning it has 3 keys. The keys are 1, 2, and 3, the string values of those. So we can say DCT or dict at 1 and that should return us its value, so the integer 1. There it is, you could see. Now I could say dct add 2, and it would return us the value 2. The dictionaries are basically indexable, however, they are indexed by their keys instead of regular indexes like we saw with tuples and lists. So dictionaries are mutable. That would mean that we can change it. We have assigned the variable dct up here, and I'm going to show you how we can change it down here. Like we did with list, what we want to do is we want to access an index of it, or in this case a key. So if I say dct at 1, and then I assign that to a new value, again, it's a collection of key value pairs. So the key 1 corresponds to the integer value of 1. But now I want to reassign this key to a new value. Let's say that value is going to be 100. And as you can see, this works. It doesn't throw us an error. So now if I go to log what the dictionary is, now you can see that we have changed this key value pair right here. So the key 1 now corresponds to the value of 100. So again, dictionaries are mutable because we can change them after they have been created. Now, like I mentioned with indexing, you index a dictionary through the keys and not through the regular indexes that we saw with lists and tuples. So what that means is that dictionaries also aren't going to be sliceable. So I can't do something like the dictionary from 1 to -1. This just won't work because we can't grab a slice of it, because again, dictionaries don't support regular indexing. They support indexing by keys. Now the last variable type we are going to be talking about is the set. And a set, from what I learned, is an unordered collection of items. However, I'm not sure in Python if it's ordered now, but basically we can create a set by saying something like we did with the tuple, where we can say set and then pass it a list of items, so like 1, 2, 3. And if I log the type of A, you can see it's a set. You can also create a set by saying B is equal to like 1, 2, 3. They are both sets. However, one thing to note in Python, when you try to create an empty set, so if I say like C is equal to this, you would think that this is a set, or you might try to create a set. However, when you just create an empty set like this, Python defaults to thinking it is a dictionary, because dictionaries and sets both use these squiggly braces. So if I log the type of C, well, it's going to be of type dict. So if you want to create an empty set, the way to go about it is using this syntax. So we can say C is equal to a set, and then we just want to pass in an empty list. Now, if we log the type of C, it will be a set. So it will just be the empty set. So that's one thing to note about Python. If you just put these squiggly braces, it defaults to thinking that it is a dictionary. Now, a set can be thought of as the mathematical set, where it is a collection of unique items, and that's true in Python as well. So if I try and create a set called A, and then I try and make it 1, 1, 2, 3, because it is unique elements, the set will only contain elements 1, 2, and 3. Again, if I log it, you can see it contains only 1, 2, and 3. And this is because sets contain only unique elements. Now, sets are not indexable, meaning we won't be able to say A at like 0 or something like that. Again, we can see that it's the error is not subscriptable, meaning that we can't access these indexes because it's as far as I know, it's unordered, but feel free to correct me if I'm wrong. But sets don't have these indices, meaning we can't slice them and we can't index them. So we can't say like from 1 on to -1. This will not work. Sets are mutable object or data types, and this can be kind of shown a little differently than I've showed you mutability before. So before if we've created like a list called L, and then we had like, I don't know, 1, 2, 3 in it, the way I've showed you that a list is mutable was by accessing an item and then changing it to something else. You could see that it's been changed. However, in a set, because there's no indexing, you can't really do this technique, but you can show that a set is mutable a different way. Again, if we go back to the definition of immutability, it means that we can't change the actual collection once it's been created. However, we can with a set. So if we look at the set A that we had, which is 1, 2, 3, we can't access elements in it by using indexing, but what we can do is we can add to that set. So we can say a dot add, and then we can add a 10 in there. And now you could see that we have changed the original set A that we had. We have added this element 10 to it. This is another way just to show that these sets are mutable. With all of these collections that we just talked about, there are multiple methods that go with it. And I suggest that you look into the Python documentation about all of them, because there are some super helpful methods, and some of them might be a little confusing. Again, look into the documentation for Python. I just wanted to quickly go over what these types were and kind of the stuff you can potentially do with them. But again, there's a lot more you can do with all of these things than just what I showed you in this video. So that's it for today's video on Python variables. Hopefully you guys enjoyed the video and learned something. Like usual, if you are new to the channel, please like, comment, subscribe. It's greatly appreciated. And yeah, I'll catch you guys in another video.